All right, 12.1 exponents, guys. So the product rule for exponents, guys. So product rule. It's very important that you guys are understanding the title of these rules because other professors and future classes are going to expect you to know product rule when they say it. And it is okay at that point at the college level for them to have that expectation since we are advancing in our education. So if M and N, so now my job here is to kind of help you build the foundation so that when you see new formulas or new theorems or new properties in other classes, you're like, oh, that makes sense. Like logically, I follow what they're saying, even though it's new to me. I feel good in what they're showing me, you know? So if M and N are positive integers, so positive, we know that means positive numbers. Integers, we haven't really gone over. Integers is just pretty much whole numbers, guys. And now all integers is there's negative whole numbers and positive whole numbers for integers. But positive means we get rid of the negative ones and a is a real number, then a to the m times a to the n is a to the m plus n. So seeing here that the product rules is if we're multiplying the same base, guys, a and a is the base, we're gonna keep the common base. The a stays there, right? A to the m times a to the n. So a could be any number. A could be 5 to the second power times 5 to the third. Like example, I'm gonna plug in a number for a, right? So let's say we have 5 to the third times 5 to the fourth. Since the base are the same, 5 and 5, this is actually 5 to the 3 plus 4, which is 5 to the 7 power. That's how we apply power. Now, the same thing works with variables, right? We can use letters, like, for example, y to the fifth times y equals, well, since there's no exponent there, it's an invisible 1, right? Keep that in mind. So that's y to the 5 plus 1, which is just y to the 6. So those are just little kind of examples of product rule, right? Now look at this helpful hint, guys. Don't forget that for 3 to the 5th times 3 to the 7th, it does not equal 9 to the 12th. That we didn't keep the common base. They actually multiplied 3 times 3 and got 9. We don't do that. That's not right. And if you look at the expansion part, this is the expanded form. Now you can use the expanded form to help you out, but that's kind of a little elementary. So kind of we learned in high school is, well, we know 3 to the 5 is 5 threes, right? 3 times 3 times 3 times 3 times 3. And we know 3 to the 7th is also the same thing, but 7 threes. And in total, we see we have a whole group of threes. So we add them all up. In total, we have 12 factors of 3. So it's the same thing as 3 to the 12, not 9. Okay. Are there any questions on the product rule? Because we're about to apply it in the first example right now. Nick and Fatima Gul, was that enough time, guys, for you to get the information before I move on? Excellent. Thank you. Thank you. All right, moving on. Here is the first example. I'll go ahead and you can write each one if you want. We have A, B, C, D, E, F. So A says, so we're gonna use a product rule to simplify. I'll go ahead and give you about a minute to copy these down, and then we'll get into it. All right, let's take a look at example A, guys. We have 4 squared times 4 to the 5th power. Now, it's very important that we're using the how to read exponents, right? Because that was the first lesson we covered in this class. So what's my base, guys? What am I multiplying? What's my base? From the example, it was letter A, right? A to the whatever power was, right? Here, what's our base here?
Totally incorrect.
4.
4. It is 4. The base is 4. And the two exponents is 2 and 5. We're to go ahead and add them together. And then 2 plus 5 is 7. 4 to the 7th power. And we're done. Now let's look at B. X to the 4th times x to the 6th. My base is x. And it's gonna be 4 plus 6, which gives us x to the 10th power. Do not forget this middle step because these are notes, guys. This tells us what steps we're doing to avoid confusion when I give you the practice problem. Now look at the C. Y cubed times y. There's an invisible 1. So then we get y to the 3 plus 1, which gives us y to the 4th power. Now D gets a bit trickier now because now we have more than 2 y's. We have 3 y's. But nonetheless, the product rule applies because it's all the same base. So we'll just be adding 3 plus 2 plus 7, which is y to the 12th power. And then let's look at E, my base. Look at the parentheses, the behavior of that. It's -5 in the parentheses. So that is the base we're dealing with. And then we are adding the 7 and the 8, which gives us -5 to the 15th power. Notice how I included the parentheses in each of the steps. And then last but not least, we have F, and that says a squared times b squared. Since they're different bases, we're actually gonna just bring it down just the same way it is and just box that in because we cannot apply the product rule because the bases are not the same. And just like that, we finish our first 6 examples. What questions do we have on the product rule, guys? If any, do we have any? Or concerns? All right, would anyone need additional time to copy this down before we bring up the practice problem, guys?
Yes, I need 1 more minute.
Let me know when you're good to go.
Okay, thanks.
Let me know when you're good to go, Joshua. Thank you, Josh. Just waiting on another student and now move on.
Okay, I'm done. Thank you.
All right, thank you for the heads up. Let's go ahead and start our first practice problem, guys. I'm going to give you guys about 3 minutes on these just because they're pretty simple. I'll add more time if y'all need more than 3 minutes. All right. Good luck, everyone. And to utilize the chat to share answers, I'm gonna show you how to write exponents in chat. So to say x squared is equal to x, the caret symbols will be shift 6. That caret symbol, this is known as the caret symbol. Which is, you press shift 6 to get it. That's how you write an exponent. Because we will be utilizing the chat to say our answers for each of the following ones. Okay, guys? Good luck. All right, guys. Would anyone need more time to work these out? Last call for more time before we start discussing. All right, let's go ahead and go over this. So for A, guys, go ahead and share in the chat what you got for A, por favor. Excellent, excellent, excellent. Agree. Thank you, Sarah. Excellent, Brianna. Excellent, Riley. Nice. Looking good, guys. Looking good. All right. Anyone have any confusion for A or need me to work out A before we move on to B? So we technically just add the exponents. 4 plus 6 is 10, so it's 3 to the 10th. Correct. Now go ahead and let's plug in our answer for B now. Everyone, please, B. All right, I see a 5 and a 6. All right, all right. For anyone like to show how they got the 5, guys? Okay, okay. Probably a typo, okay. So remember, for product rule, guys, the one thing we need to remember is what do we do to the exponents when there's the same base, guys? What is the rule of thumb? If you're multiplying the same base, what do we do to the exponents? Before we move on to C. Anyone, you can type it in the chat or you can unmute yourself.
Add them.
Add them, correct. Thank you, thank you, thank you. All right, let's see if anyone made a mistake with C, all right, Z. What's Z times Z to the 4th, guys? Plug in your answer for C. Excellent, excellent. Love the confidence, Joshua. Love it, love it. Excellent. Hashtag nerd status. Hashtag algebra is life. Excellent, guys. Good, good, good. You guys remembered if there's no exponent, it's an invisible one, and 1 + 4 is 5. Excellent job, guys. Excellent, excellent. Let's move on to D, por favor. So go ahead and share your answers for D. X cubed times x squared times x to the 6. Oh, we're plugging in E as well. Let's go ahead and let's make sure we do D first, right? Let's get into D. No, you're good. We lose track sometimes when we do math, so that's fine. It happens, Nicholas. Happens to the best of us. All right, x to the 11th. Excellent job again, guys. X to the 11th is correct because 3 + 2 + 6 is 11. Now let's go ahead and see your submissions for E, guys, to see how you type it in. Very, ooh, nice. Nice use of the parentheses, everyone. Good, good, good. Now, can someone tell me if I forgot the parentheses, are they still equal? Is my answer without parentheses the same thing with parentheses? Yes or no? Good, good, Priscilla. Excellent, excellent. I hope Priscilla's not the only one that knows they're not the same. Hopefully everyone knows at this point that parentheses around exponents matter. All right, all right. Let's see how everyone did with F. Final answer, y'all. Final answer, F. Excellent, excellent, excellent. And can someone share the reasoning why we write down the same thing for the answer as well? Why does nothing change? Anyone want to share?
The two bases are different.
The two bases are different. The base is not the same. I love that y'all use the word base. That's awesome, guys. Good, good choice in vocabulary. I think that's a tier or it's allergies. Nah, you guys are doing great. Okay, good, good, good. So everyone feel good so far. Now remember, this is just like the baby ones, right? We're building our foundation right now with the smaller examples because it's gonna get a little intense, guys. And like I said, it's gonna get intense just like now. But do not freak out, right? The point of this is we're exposing ourselves a little bit and taking our time with it, okay? So I'll go ahead and give you about a minute to copy some of these problems down before I get into A, okay? Then we'll get into it in a minute. Good luck. I'll see you. I'll get started in a bit. All right, guys. So let's take an example A. So notice how the product rule only says at the exponents, right? It was a to the m times a to the n. I'm gonna write it off here to the side what the product rule said over here. It was a to the m times a to the n is equal to the a m plus n, right? But it never said anything. What if there's a coefficient in front? Like, what if there's numbers in front? What happens to those numbers? Well, remember, the name of the rule is called product rule, right? And product is the answer of what type of problem, guys? Product is the answer of what type of problem? Anyone? Product is the answer of a multiplication. A jinx. You know, me a Coke. So yeah, it's an answer of a multiplication problem. So we're gonna multiply. So you know, we have 2x squared times negative 3x squared. We're gonna go ahead and multiply the 2 times the negative 3. And then with the exponents, we know the rule is we add them, 2 plus 5. So let's go ahead and multiply the two numbers, 2 times negative 3, which is negative 6, and then add the two exponents, which is 7, and thus finishing off the problem. Does everyone see what happens now if we have numbers in front? We multiply them and then we add the exponents of the same base. Now look at B. B switches it up now because now there's no coefficients. Now we have two variables to consider. Now, technically, guys, there is numbers in front of these variables. What numbers there that we cannot see? Anyone?
One.
Yeah, there's an invisible one, but do we necessarily have to write the one class?
No.
No, we don't. We don't. Oh, like we could have won, but we don't have to. So we could drop the parentheses at this point. If we want, we can just write them right next to each other, right? Without them. Because remember, when we have letters next to each other, they're just technically multiplying. On A, you can also drop the parentheses too, because remember, to show multiplication, I chose parentheses because I could have done this 2 dot negative 3, but that looks more confusing. So I use parentheses around them. And yeah, so remember, multiplication isn't safeguarded by parentheses, but they're just there. But now for B, we move on. So now let's look at the X's. On the answers, well, where would we need the need for it? Because remember, we're used to having numbers in front of letters. Now, if you do this, adding that is the same thing as the way it is without them. So they're kind of unnecessary. No. Your final answer will be best, just like this, -6x to the 7th. And then now let's look at B. We have two variables, so let's look at the X value. So what's my exponents for X? We're gonna add a 2, and then we have a 3 over here. Now for the Y exponent, we have an invisible 1 plus 2. Notice how we kept the exponents with X's and the exponents with Y's, and now we simplify. 2 plus 3 is 5, while 1 plus 2 is 3. Thus, since they're different bases at this point and we cannot combine them, we box it in and we're done. Any questions on what I've done so far for A or B so far? Any other questions? All right, let's look at C. Now here we have coefficients again. We have an invisible -1 here in front of the C, right? So we're gonna multiply -1 times 3 for the coefficient. And then for the A value, what are my exponents for A that we're gonna add, guys? 7's the first one. Can someone tell me the second one? Plus what?
1.
1. And then for the B's, what exponents for my B am I gonna add?
7 and I'm sorry, 4 and 9.
Excellent, 4 and 9. And now we simplify. -1 times 3 is -3. So we're multiplying these two. And then 7 plus 1 is 8. And then B plus 4 plus 9 is 13. Now, since look at it again, can we do any other rules? No, we cannot. So we are done. Now, if you want to make a little quick note, guys, you can write no. Multiply the coefficients, comma, if any, and always add the exponents if the same base. Would y'all say this note summarizes what we do for these examples, guys? Would y'all say this note kind of sums it up for us? Now, if it doesn't, if it confuses you, because I'm not really good with words, you can feel free to paraphrase it for your benefit, please. But I always found some notes to write whenever we add something to a rule or property, tends to kind of help a little easier. Any questions so far before we move on? All right, so no questions. Here is the practice problem, guys. I'm gonna go ahead and give you guys about 3 minutes on this one. I'll add more time if needed, okay? Good luck, everyone. All right, that was 3 minutes, guys. Does anyone need more time than the 3 minutes before we start discussing it? Remember, we're using product rule. All right, I'm gonna go ahead and add, would you like 1 or 2 more minutes, Brianna? 1 or 2? All right, I'm gonna add 1 minute more. Good luck. All right, that was the additional minute, guys. Let's see how everyone did. Okay, so go ahead and share your answer for A, guys. For when you have a coefficient, you just have to write the number in front of the letter. Okay, no symbols between the number and letter. You don't have to. You could include it, but it's unnecessary. Excellent, excellent, excellent. Right, because a -5 and a -3 both makes it a positive. And then we add 3 and 7. Good job, everyone. 15 white to 7 is correct. Anyone have any questions on A or need me to work out A before we talk about B? Anyone? Excellent, 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 guys. All right, all right, all right. Start typing your answer. Now, the only typo in yours, Nicholas and Fatima Gul, is you are missing the Y after the 15, but I'm sure you have it written down. So just make sure when in my math lab, you include the letter as well, okay? Because it will be like incorrect and stuff. So, all right, let's go ahead and do our answers for B. Excellent, excellent, excellent. Y to the 12th power times Z to the 4th power. That is correct. Any questions on B so far, guys? Any questions? Good correction, Sarah. Glad you saw it. Glad you saw it. Anyone else? Excellent, Fatima Gul. Excellent, excellent. All right, so far so good. Correct again for B. Now, last but not least, let's go ahead and input our answers for C. Good luck. All right, -7 m to the 5th times n to the 14th. So far, there's been a consensus. Just seeing if anyone else is still typing before I say right or wrong. So we got -7 times m to the 5th times n to the 14th. You are correct. Good job, everyone. Thank you so much for participating in these practice problems. Now, does anyone have any questions, comments, or concerns so far regarding these practice problems, guys? Any questions at all? Do y'all feel fairly confident in yourselves of when and how to apply the product rule moving forward? Because there's gonna be multiple rules we're covering in today's lesson. It's gonna be kind of the most jam-packed now for the rest of the semester. This is the most intense one. So, everyone okay so far?
Sir, can you go back to the last slide? I just want to double check something.
Yeah, of course. Here you go. Let me know when I'm good to go.
Okay, you're good. Thank you.
All right, excellent. All right, let's go ahead and move on, guys. And now we're learning the second rule of exponents known as the power rule. I'll go ahead and give you about 3 minutes or 3 minutes to write the rule and the exponent down. Okay, guys? Good. And I'll work. Go ahead and start talking about it. Good luck. And if you're able to read the rule and write down the rule and the exponent and you feel confident in what the rule is saying to do and how to do it on the example yourself, feel free to do it on your own and compare with my answers, right? When I work them out. But if you do not feel comfortable to do that, then just simply wait to the timer for me to get started, okay? All right, let's take a look at example A, guys. So before we get into A, let's look at the power rule. Remember, this is our second rule of exponents we're learning right now. So power rule for exponents. If m and n are positive integers, which we now know what positive integers are, and a is a real number, then a to the m to the n power equals a to the m times n. So we're multiplying the exponents while keeping the same base. Now, looking at that logic, use the power rule to simplify y to the 8th to the second power. So it's a power to a power. Then we're not multiplying same base because there's only one base now. We're going to go ahead and multiply the two exponents, 8 times 2. And we know 8 times 2 is 16. And thus we're done with A. B, 8 to the 4th power to the 5th power, power to a power. We're going to go ahead and multiply the 4 and the 5, 4 times 5, which is 20. And thus we're done with B. Now C is negative 5th to the 3rd power. So it'll be negative 5, not 5th, negative 5 to the 3rd power times 7, since it's a power to a power. Thus, our result will be 3 times 7, which is 21. And we are done. We have officially learned and applied the power rule. Any questions so far on any of the procedures we just did, guys? All right, anyone need a quick second to write these down before I move on? All right, let's go ahead and get into the practice problems. Use the power rule to simplify z cubed to the 7th power, 4 to the 9th to the 2nd power, and negative 3 to the 5th power. I'm gonna go ahead and give you guys 2 minutes on these, and we'll go ahead and discuss them after the 2-minute timer. Good luck. All right. For A, guys, what did y'all get for A? Or did anyone need more time than the 2 minutes? All right. Z to the 21st power, 21 power. Excellent, excellent, guys. That is correct. Anyone else would like to share their answer for A before moving on to B? Or does anyone have any questions on what we did for A? All right, guys, go ahead and let's move on. For B, what did everyone get for B? 4 to the 18th, 4 to the 18th. 4 to the 18th. Excellent, excellent, guys. Good, good, good. Now for this one, you can include or exclude the parentheses around the 4 because the 4 being positive would never change. Whereas if the 4 was negative, would impact the way the exponents should be written with the parentheses, right? So you can include it with or without. Good job, everyone. 4 to 18 is correct. Last but not least, go ahead and let's input our answers for C. All right, guys, so we have a couple of exponents with parentheses and without. Would anyone like to share with the class? Is there a difference for this one? Would anyone like to share if the parentheses makes a difference for C?
No.
Okay,
Yes, because it's a negative number.
that is correct. So C is saying what is cubed? What number is being cubed? Someone share or tell me. What number is being, what's being to the power of third or 3 on C? The -2 is, right? Now, when you don't include the -2, so this is -2 to the third power. This is saying it is saying is -2 cubed. Not the same thing. So this is saying this is the without parentheses is saying it wants the negative of 2 cubed. Whereas with parentheses, it's saying that it's -2 cubed. That is the power to the third power. And if you look at C carefully, the parentheses are there to tell you and tell us, the reader, that -2 is being cubed. Whereas without the parentheses, you're negating 2 cubed. So for example, -2 cubed is actually -2 times -2 times -2. Whereas -2 cubed, that's just -2 times 2 times 2. But if you look at it carefully, we're not cubing, this is cubing 2. We're not cubing 2, we're cubing -2. Okay, cool, cool, cool. Did that visual help out, Sarah, with the differences? Okay. Very important that you know the difference, guys, from like when to utilize symbols, because these symbols make a difference if you're an accountant, an engineer, and you're dealing with these math, because you do use math in those important fields, and you have to know the difference of how to use arithmetic, because if you don't understand arithmetic well and you make that the wrong judgment, you could impact a project or something that you're doing, okay? So, all right, Fatima Gul, do you understand the difference, ma'am, of why it's important to include the parentheses? Yes, okay, let's move on. All right, I was gonna have you not write this down, but with the little confusions we've had a little bit with the two rules, I do want you to write them, the differences of these two. So I'm gonna go ahead and give you guys about 3 minutes to write these down. Good luck. All right, guys, that was the 3 minute timer. Would anyone need more time to take this helpful hint down? Anyone else? Before we move on.
I need more time.
All right, would you like 1 or 2 minutes? 1 or 2.
2 minutes. And if I get done sooner, I can let you know.
Thank you so much.
Okay, I'm done. Thank you.
All right, let's go ahead and move on. Now we're learning, now this is not a rule, it's an extension of the product rule. It's an extension, so this is not a new rule, it's an extension. So I'll go ahead and give you about 2 minutes to set up this extension and this example, so we can jump into it, okay? All right, let's talk about this extension, right? So it's saying the power of a product rule. If n is a positive integer and a and b are real numbers, then 8 times b to the n power equals a to the n times b to the n. So we can see here is if we have multiple things inside of parentheses being multiplied, if there's a power on the outside, we pretty much distribute that power to everything in the inside. So at that point, let's look at A. S to the T, S times T to the fourth power. So we know S and T are being multiplied. So if you look at it, I'm going to show you the expanded form. ST to the fourth power is pretty much ST times ST times ST 4 times, right? Because that's what the exponent's saying. So at that point, how many S's do we see? S to the fourth, and then we see T to the fourth, which is pretty much just distributing that exponent. But I went ahead and showed you the expanded form. For the other examples, I'm going to go ahead and just use the distribution part to avoid any confusion, okay? So 2a cubed, pretty much that cube is going to go to the 2 and to the a, right? So I'm going to do 2 cubed times a cube. Well, guess what, guys? 2 cubed, that's 2 times 2 times 2, which is 8, and then a cube. Now, the reason why we go another step forward is because 2 cubed could be simplified. Right now, it's not telling us. If it told us apply the power of a product rule for each expression, then we will stop in the first line. But since they want us to simplify the expression, 2/3 can simplify to something else. 2 to the third power or 2 cubed is the same thing as 8. So that's why we go another step forward in this example. Everyone with me so far?
No, can you explain that again?
Okay, so we have 2a cubed. So we apply the property, right? If we have an exponent on the outside, we put it with each thing being multiplied. Well, we have 2 and a being multiplied in the parentheses. So the cube is on the outside. So we're gonna go ahead and give the cube to the 2 and to the a. And there we get 2 cube, 8 cube. Now, the reason why we go another step forward is because it wants us to simplify the expression. And 2 to the third can be simplified. It's actually a number. It's a value. It's 2 times 2 times 2, which is the 8, which is why we go another step forward and evaluate it for 8. And then we bring down the 8 cube because there's no way to simplify 8 cube any further. And there we're done. So wherever we have the value to do more, we have to do it. So let's look at C, 1/3 mn cube. We're gonna go ahead and apply that square to each of those terms inside the parentheses. So the 2 is gonna go to the 1/3, it's gonna go to the m, and it's gonna go to the n cube. So then we're gonna get 1/3 squared. Then we're gonna get m, and there's an invisible 1 times 2. And then we have n to the 3 times 2. Because there's an invisible 1. Because remember, when we have a power to a power, 2 powers next to it, they have to be multiplied. Because that's the power rule, right? Eventually. So 1/3 squared, 1/3 times 1/3. So we multiply the two fractions. 1 times 1 is 1. 3 times 3 is 9. And then 1 times 2 is 2, so it's m squared, and then n to the 6. So it'll be 1/9 m squared n to the 6, and we're done. Now let's look at D. We're gonna go ahead and distribute the square to the 5, to the x squared, the y cube, and the z. So then we get -5 squared. Then we get x squared to the second power, so we multiply that. Then we get y cubed to the second power, multiply that. And then z times 1 times 2. So let's go ahead and simplify that. -5 squared is -5 times -5. 2 -5s is a positive 25. 2 times 2 is x to the 4th. 3 times 2 is y to the 6th. Z is 1 times 2, which is 2. After we simplified everything, if there's no other rules to do, we go ahead and box our answer and we're done. What questions do we have on applying this extension of the product rule? Any questions at all? Does everyone okay with why we multiply these? Because we're doing a power to a power, right? We're applying the power to each term. So we have to multiply them using the power rule. And then these are numbers. So -5 squared, that's gonna equal a number. So that's why we go another step forward with that, you know? Any questions before we jump into the practice problem?
I just need a minute to copy the rest.
Okay, let me know when you're good.
Okay, thanks. Okay, I'm ready. Thank you.
Thank you. All right, guys, we're gonna go ahead and apply this extension to this example here. I'm going to give you all 3 minutes on this one, and I'll add more time if needed. Good luck. All right, anyone need more time to do these practice problems before we start discussing these? Any more time?
Yes, I need more time.
Would you like 1 or 2 more minutes? 1 or 2?
2.
All right. Good luck.
Thank you.
Now, keep in mind, guys, as you work these practice problems, if the numbers have exponents, it is your job to evaluate those numbers, okay? And not leave it as 6 squared, but what is 6 squared? Okay, like the last example. Good luck. All right, guys, let's go ahead and take a look at A. Let's go ahead and share our answers in the chat with A. Excellent, excellent, guys. We're getting P to the 5th power times R to the 5th power. Excellent, excellent distribution of the power rule of the product rule, guys. Good job, good job. If you got P to the 5th times R to the 5th, you are correct. Are there any questions on what we do for A? Or the answer for A? All right, anyone else would like to share their answers before we move on with B? All right, let's go ahead and submit our answers for B, our final answers, guys, okay? All right, we have 36B squared for B. A lot of 36B squares. If you got 36B squared for B, you are correct. Good job, everyone who submitted 36B squared. Any questions on what to do for B? All right, let's see how everyone does. Now, before you type in the answer for C, to type in a fraction, it'll be like 1/25. And you can just press space, right? And then type in the other letters with it, whatever it is, right? You know, I'm just guessing with whatever. So giving you an impact that C should be, there should be a fraction into your answer. So, all right, go ahead and share your answer for C now, everyone. Or anyone else worked out C and would like to share with their answers real quick? All right, C is where we start getting a lot of differences in our answers. So let's take a look at C, right? So we're doing pretty much the 1/4. Everything gets the cube, right? And we have the 1/4, the X, and then the Y. So then we're gonna get 1/4 to the 3rd power. Then we're gonna get X squared to the 3rd power. And we're gonna get Y to the 3rd power. We pretty much distributed to all of them. Now, 2 to the 3rd, we're gonna have to multiply here, and there's a 1 here, multiply here. But let's do the 1/4 first, though, right? 1/4 cube is pretty much gonna be 1/4 times another 1/4 times another 1/4. So let's multiply all the ones. 1 times 1 times 1, that's just a 1. 4 times 4 is 16. Then we're gonna do 16 times another 4, which is 64. So we just multiplied across. And now remember, we have a power to a power, right? The 2 and the 3 and the 1 and the 3. When we have a power to a power, we multiply that. So we're gonna get X to the 2 times 3, which is 6. And then 1 times 3, which is 3. So make sure that you're giving out the cube, the exponent, to all the variables and coefficient, okay? Make sure you pass it on to all of them. Does everyone see how I did C? So for this step, I'll do X times 2 times 3. I'll do Y to the 1 times 3 for that second step. All right, any more questions for C before I have you input your answer for D? Speak now. or think about a question and then feel free to ask me later. D. All right, guys, let's go ahead and share your answers for D. What did y'all get for D? It's a pretty juicy one, so good luck. Or is anyone still working on D?
I'm still working on D.
Put a 1 by it. See the Y at the top?
Okay, I'm gonna go ahead and include, and I'm gonna go ahead and give you guys an extra 2 minutes, okay? 2 minutes. Then we'll go ahead and discuss D. All right, guys. Hopefully those 2 minutes was enough. Anyone want to share what they got for D in the chat, please? Anyone? 81, A to the 12, we have B to the 16, and C to the 4th. Now we have a positive 81, we have a negative 81. Interesting. We have a couple, okay, 2 negative ones, okay. Now Annette and Fatima, good for when y'all did -3 to the 4th power, did you guys use a calculator or do it by hand?
I use my phone.
Okay. Now, if you're using your phone to multiply, it's important that we know what's going on, right? So when you on -3 to the 4th, guys, on this part right here, if you're using your phone calculator, it's important that when you type it in, you're writing in -3 times -3 times -3 times -3. Because that's really what it's doing with that exponent is we're multiplying -3 to itself 4 times. So when you do it like that, when you type in -3 times itself 4 more times or 4 times in total, what kind of 81 do y'all result into? Because I don't think you can type in exponents, right, on our phone's calculator. Or can we?
I'm able to, but I see where I did it wrong. I think I missed one of the negatives.
Ah, okay,
It
okay.
threw me off.
Okay, okay. And sometimes always writing it out and double checking with your calculator a couple times doesn't hurt. But with practice, luckily we can talk to each other about it. But when you, especially when you work on your assignments, always do those double checks, okay?
Okay,
So here, when you see that two negatives make a positive, right? -3 times -3 is a +9. This is also a +9. Multiply those two together, we get 81, a +81. And we do a power to a power, which gives us a to the 12, b to the 16, and c to the 4th. I noticed we didn't have any mistakes with the exponents for a, b, and c. So good job, everyone. For the coefficient part, the 81 and -81, no worries. As long as you understand what to do moving forward, just to double check yourself, okay, guys? Are there any questions so far on what we did in any of these practice problems, guys? Everyone feel okay with them? So it's very important that moving forward, that if you see these types of problems on your homework, you're able to deduce or figure out the steps on your own, okay? Making sure you're looking at your notes that we do in class. All right, let's go ahead and move on. So now we have another extension so far. So it's pretty much tells us that we have an exponent outside of a fraction, we can pretty much put the exponent into the fraction. So I'll go ahead and give you guys about 2 minutes to set this up into your notebook before we jump into it, okay? All right, guys, let's take a look at this one. So this extension of the quotient rule, which is the one we haven't gone over yet, but you'll see momentarily. It doesn't really need it for this one. So if n is a positive integer and a and c are real numbers, then a over c to the n power is the same thing as a to the n over c to the n, and where c cannot be 0. So essentially what this extension is saying is, if we have a fraction with an exponent on the outside, pretty much the exponent gets transferred to everything at the top and everything to the bottom. Everything to the bottom. So for A, it's a little bit easier because M and N are separate, so different bases, so nothing happens there. And they're both on top and bottom, so we just pretty much put the 7th. Now for B, it gets a bit juicier because now we have a power on top. So pretty much what happens is we get x cubed to the 4th power on top. And then we get parentheses, 3 to the y fifth to the bottom. Well, luckily, we already know a power to a power, and we know the power to a product. We know these things already, so let's apply the rules we know. So here, a power to a power, we're gonna multiply the two exponents. And then the bottom, we're gonna go ahead and distribute that exponent to everything in the bottom. So we're gonna get 3 to the fourth power, right? And then we're gonna get y to the fifth to the fourth power. So we're having another power to a power. But we're not done yet. We have to simplify now, right? Well, we know 3 times 4 on top is x to the 12. And we know 3 to the fourth. 3 to the fourth is 3 times 3 times 3 times 3, which is just 81. And then here we have y to the fifth to the fourth power. We know we're gonna have to multiply these things that we did over here with the 3 and the 4. So 5 times 4 is 20. And just like that, we're done. What questions do we have with this extension, guys, if any? All right, since there's no questions, guys, let's go ahead and try practice problems. Is everyone is everyone good with copying this already? All right, here is the practice problems, guys. Good luck. I'll go ahead and give you guys 3 minutes to start, and then I'll add more time if needed. Good luck. All right, all right. Anyone need more time or y'all ready to discuss?
I'm working on the second one, almost done.
All right, would that go 1 minute or 2?
One.
Okay, we'll go ahead and get started after 1 minute, guys. All right. That was the additional minute, guys. Go ahead and put in your answers to the chat for problem A. Remember, / is the way to separate a fraction, guys. Same concept with the exponents too. Excellent, Tanya. Great input. Great job, Annette. Excellent job, Fatima Gu. Excellent, Nicholas. Excellent, Riley. Excellent, Brianna. Excellent, Sarah, for green. Okay. Anyone have any questions on A before we discuss B? Anyone? All right, let's go ahead and input our answers for B now in the chat, or answers for B. Look at your coefficient 10. Remember, if I think I go 2 to the 5th is not 2 times 5, ma'am. It is a power. So it's 2 to the 5th is 2 times 2 times 2 times 2, 5 times, okay? It's a power. This is an exponent lesson. Excellent. Make the changes into your notes, okay? All right, we have 32a to the 20th over b 15th. Excellent, guys. If we got 32a to the 20th over b to the 15th, you are correct. Anyone have any questions, comments, or concerns regarding either of these practice problems, guys? Yes, I'm gonna go ahead and work out B. So 2 to the a4th over b to the 3rd. Remember the rule that we just learned, the extended rule is we have a quotient, a fraction with an exponent. The exponent goes to the top, so it'll be 2a to the 4th to the 5th power over b to the 3rd to the 5th power. Well, the top part, there's 2 of these things, 2 and 8. So we know that the 5 is going to distribute to the 2 and to the 4. So we're going to get 2 to the 5th, a to the 4th to the 5th. Just like the bottom is b to the 3rd to the 5th. When we have a power to a power, guys, we're technically multiplying the 2 numbers. Well, and we know 2 to the 5th is just 2 times 2 times 2 times 2 times 2, which when you multiply that out, you get 32. And we know we're multiplying 4 and 5 because it's a power rule, so it'll be 4 times 5 over b to the 3 times 5. When we simplify that, we get 32a to the 20th over b to the 15th power. And we're done. Any other questions, guys, regarding any of these practice problems? All right, let's go ahead and move on. Now we're in the last rule, or not the last rule, it's actually not the last rule, but we're in the next rule, the third rule, quotient rule. We've done product rule and we've done power rule. So now we're on quotient rule. I'll go ahead and give you 2 minutes to set this up into your notebook before we jump into it. All right. So let's take a look at this quotient rule, class. So we're here. It says the quotient rule for exponents is if m and n are positive integers and a is a real number, then a to the m over a to the n equals a to the minus n. So notice that we're doing the top minus the bottom. All right, so let's go ahead and so now we know for this one, we're gonna go ahead and be subtracting the exponents, right? So let's take a look at example A. Excuse me. All right, let's look at A. Our base is X, right? They're both the same letter. So X to the 5th over X squared is the same thing as X to the 5 minus 2. And we have to simplify though. It wants us to keep going. So 5 minus 2 is X cubed. Since X is a variable, not a number, we cannot simplify anymore, so we are done. Let's take a look at B. 4 to the 7th over 4 to the 3rd power. So we're gonna go ahead and, it's a quotient rule, right? So it's gonna be 4 to the 7th minus 3, which is 4 to the 4th power, which it's a number, so we can simplify again. So it'll be 4 times 4 times 4 times 4, which is 16 times 16, which is 256. And we're done. C, look at the base in parentheses, -3. And it'll be 5 minus 2, which is -3 to the 3rd power, which is -3 times -3 times -3, which should give us a -27. D is S squared over T cubed. The variables are different, so guess what? We cannot do quotient rule, so we're done with that. And then on E, we have 2 divided by 1, right? As an invisible 1 here. And 2 divided by 1 is just 2. And then we have X's, right? So then X, we have 5 over 1. So it'll be 5 take away 1. And then for the Y's, it'll be 2 take away 1 as well. So then simplify that. So it'll be 5 minus 1 is 4. 2 minus 1 is 1, which is just Y. And we're done here. Any questions on how I did the quotient rule? Or any of the simplifying I did? Any questions? All right, anyone need more time to copy before I give you the practice problems?
I need more time to copy.
Let me know when you're good.
Okay, I'm done. Thank you.
All right, here's another practice problem. I'm gonna go ahead and give you guys about 4 minutes and I'll add more time if needed. 4 minutes and I'll add more time if needed. Good luck. All right, class. Anyone need more time to work these out before we jump into it, guys?
Yes, I need more time.
Would you need 1 or 2 or 3 minutes? 1, 2 or 3?
Mm,
2,
3 minutes is good.
3 minutes?
If I get done sooner, I can let you know.
Okay, I'll put 3 minutes and if you're done sooner, let me know.
Thank you.
Thank you. All right, guys, let's go ahead and get started. Let's go ahead and share what you got for A in the chat, please. Using that quotient rule, what do we do? All right, we got Z to the fourth, guys. You are correct. Good job, guys. Any questions on what we did for A? Remember, we're using the quotient rule, so we are subtracting the exponents. Let's go ahead and input our answers for B. Remember to simplify if possible. Excellent. Positive 25 is correct. Excellent, guys. Any questions on the process for B? All right, let's go ahead and move on. Let's go ahead and share what we got for C. Excellent, guys. 64, 64. Good, good, good. Right? Because 8 minus 6 is 2, so we're left with 8 squared, which 8 times 8 is 64. Excellent, excellent. Any questions for C before we move on? All right, let's go ahead and input our answers for D, guys. D. Excellent, guys. Excellent, excellent. Again, Q to the 5th over T squared. Sarah, did you meant to put the -2 with the T? Now, your final answer can never have a negative exponent. So, and we're not covering negative exponent till another few sections from now. So pretty much D is just the same thing as the original answer, since we cannot apply the quotient rule. So it should be Q to the 5 over T squared, a +2. Now for E, last but not least, everyone, go ahead and input your last answer for E. Excellent, excellent, excellent. 6x squared, y squared. That is correct. Are there any questions or comments for E? Right, we're just using the quotient rule twice, right? We're doing 3 minus 1 for the x's, which is 2, so it's x squared. And then for the y, we're doing 7, take away 5, which is still a +2. And then there you go, it leaves us with the y squared.
Can you show your work on that one?
Yeah, of course, for E, yes. So the first things first, guys, we go ahead and divide the coefficient, right? 6 divided by 1, right? Because there's an invisible 1 here, which is 6. And then we're gonna go ahead and do the quotient rule, 3 and 1 on top, so it'll be 3 minus 1. And then for the y's, we're gonna have 7 take away 5. Go ahead and simplify those. So then 3 minus 1 is 2. 7 minus 5 is 2. And we can't simplify anymore. So we are done. Any questions for the steps for E, guys? Any questions at all? All right, let's go ahead and move on. Now we're touching base on another rule, zero exponent, guys. So pretty much saying a to the 0 equals 1 as long as a is not 0. So anything to the 0 power will be 1. I'll go ahead and give you about 2 minutes to copy this down before we jump into it, okay? All right, is anyone still setting up or am I able to start?
I'm still setting
Let me know when you're done setting up so I can start, okay?
Okay, I'm done setting up.
All right, let's take a look at number A or letter A. 3 to the 0. Now remember, zero exponent. If anything has a zero exponent, it's always going to be 1. Now, if it's not in parentheses, now remember the rules of parentheses is everything that's in the parentheses is also having that exponent on the outside, right? So let's look at A, 3 to the 0. That's just 1. Nothing else to do there, right? Because 3 to 0. Look at B, 5x cubed y squared, all in parentheses, so all of that to the 0 power, which once we have the whole thing to the 0, that's just what? 1 again. -5, it's in parentheses to the 0 power, and that's also 1 as well. Right, because it's the -5 is in parentheses. Let's look at D. -5 to the 0. Well, only 5 to the 0 is to the 0 power. Only this is 0. So that means we're doing negative to the 1 power, which is just -1. Because 5 to the 0 is 1, but it's still negative, so it's -1. Remember, a fraction to a fraction to the power, we put the power to the top and bottom. That's 3 to the 0 over 100 to the 0. Which is just 1 over 1, which is just 1. Now for F, last but not least, guys, which one has a 0 exponent for F? Is it the X, is it the 4, or is it both? 4X.
It's just the X.
Just the X. So it's gonna be 4 times X to the 0. It's gonna be 4 times X to the 0, which is 4 times 1, which is just simplifies to the value of 4. Now, 0 exponents are quite easy. It's just depending how they're inputted to the expression determines if everything becomes 1 or if it's just 1 letter and not the coefficient, or if it's, you know what I mean? It's very, you need to know the difference from parentheses, no parentheses, and so forth. Any questions on any of these examples? All right, let's get into the practice problems, guys. I'm gonna go ahead and give you guys about 3 minutes on these, okay? Good luck. Alright, anyone need more time to work these out before we start discussing them, guys? Any questions or more time? Alright, let's get into it. Go ahead and share your answer for A, guys, in the chat. What did y'all get? Alright, we have -1. Excellent. Good job, good job. A is correct. It is -1. Alright, any questions on A before we move on? Alright, let's go ahead and share your answers for B, guys. What did y'all get for B? +1, okay, okay. If you got a +1 for B, guys, you are correct. Good job, good job. Alright, alright. Let's go ahead and plug in our answer for C. Another +1. Okay, okay. If you got 1 for B and C, you are correct. Any questions on A, B, or C before we move on to D? All right, go ahead and give me your answer for D now. D. So far, so good. It is 1 again, guys. All right, all right. Are there any questions on the work for D before we move on? Those parentheses definitely make things a little clear for us, right? To understand that 0.2 is the entire thing as being to the 0 power. All right. So far, so good, guys. Let's see how you do with E. So far, so good. It's a whole mess, right? But once again, seeing the parentheses around the entire thing and to the 0 tells us like, hey, the whole thing is going to become 1 at the end. All right, so far, so good. Let's see if we can finish off strong. What is F? Excellent, excellent, excellent. It is 7. 7. Now, is there any questions, guys, so far on 0 exponent or any of these practice problems, guys? Any questions whatsoever? So this was, so A was, I forgot this is a video and the chat doesn't go into the video. So -1, B is 1, C is 1, D is 1, E is 1, and F is 7. So far, good job, guys. All right, let's keep moving on. So now we're gonna go ahead and kind of get into different types of, now they're not gonna tell us what to do, what power, what rules to do. We have to look at the problem and figure out what properties to apply to get the solution we need. All right, let's look at A. X to the 7 times X to the 4th. Anyone can tell me the name of the product that we're gonna be using? The name of the rule, I mean, property, I mean. I think I said it right. I said product. Alright, we're gonna use product rule. So X to the 7 times X to the 4th is X to the 7 plus 4, which is just X to the 11th. Alright, look at B. We have T over 2 to T to the 4th power. So we're gonna, that's a quotient with an exponent, so we get the power to the top. And we give it to the bottom. T to the 4th stays the same, but 2 to the 4th is 2 times 2 times 2 times 2, which is just 16, and we are done. C, 9y to the 5th squared. We have a square which gets distributed to the 9 and to the y to the 5th. So then we get 9 squared, then we get 9y to the 5th squared. 9 squared is just 9 times 9, which is 81. And then we go ahead and multiply the two exponents, 5 times 2, which gives us 81 times y to the 10th power. All right, any question on any of the steps we did here? All right, let's move on. Another example, guys. Simplify each expression. 4 squared minus 4 to the 0. Give you about a minute to set these up before we jump into it. All right, let's take a look at this one, guys. So once again, we know we're comfortable with exponents now. We know the rules, we know how they go. So let's go ahead and do it. Let's look at A. 4 squared minus 4 to the 0. 4 squared is 4 times 4, which is 16. 4 to the 0 is just 1. 16 take away 1 is 15. Can't do anything else, so we're done with A. Here we have a power, we have x to the 0 cube plus 2 to the 0 to the 5th power. Well, x to the 0 is just 1. We still have the cube there. 2 to the 0 is just 1, and we still have the 5th there. 1 times 1 times 1 is just 1. 1 times 1 times 1 times 1 times 1 times 1 is just 1. 1 plus 1 is 2. And we're done with B. Now C and D gets a little intense, but nothing impossible, guys, okay? Nothing impossible. So we have a numerator and denominator, and we have a square on the outside. We know when we have an exponent and a fraction, we know the top, 3y to the 7 gets the square, and we know the bottom, 6x to the 5th gets the square too. Well, we have a power to a product, right? So guess what? This power goes to both of these products, both of these numbers. So 3 gets the squared, so then we get 3 squared. And then we get y to the 7th, that gets squared too. And the bottom we get 6 squared, and then we know x to the 5th gets squared too. Can someone tell me what happens to our exponents here when we have a power to a power? Anyone remember the rule?
You get multiplied.
Yes, we're gonna multiply them, but first let's do 3 squared first. 3 squared is 3 times 3, which is 9. And we're gonna multiply 7 times 2, which is 14, over, keep going. 6 squared is 36, and we know we're multiplying 5 times 2, which is 10. But take a close look at 9 and 36. That can be simplified even further. 9 goes into 9 one time. 9 goes into 36 4 times. Notice how we have the y 14th and x to the 10th. Now, question, guys, can I do quotient rule with the y and the x? Yes or no? Can I apply the quotient rule? Can I subtract 14, take away 10? And simplify it another step forward?
No, because
Yes.
they're different bases.
Oh,
No, right, because of the different bases. We have y and x. We can only do any of the exponent rules if the base is the what? If bases are the same. Is everyone comfortable with C, with how we did C? Definitely important that you watch this again if you were lost or not comfortable with it. So first things first, we gave the power to the top and the power to the bottom. And then we distributed to the numbers and the letters, and everything got squared, right? The 3, the y7, the 6x 5th. And then we do a power to a power, which is multiply. We did 3 squared, which is 9, 6 squared, which is 36, and so forth. And then we just simplified further. All right, let's take a look at D. We have a parentheses, a product, 2a cube, b to the 4th to the 3rd power. So we know this cube is gonna go to the 2, the a, and the b. So then we get 2 cube. And then we get a cube cube. And then we get b to the 4th cube. And then over -8, a to the 9th, b squared. Nothing happens yet to the bottom, right? So 2 to the 3rd power, 2 times 2 times 2 is just a +8. And we have a power to a power class, which we know from the last example, we multiply them. So we get a to the 3 times 3, which is 9. And then we get b to the 4 times 3, which is 12. Over -8, a to the 9, b squared. Can someone please remind me what we do with the 8 and -8? Am I gonna multiply, divide, subtract, or add? Since it's a fraction.
Divide.
Divide. 8 divided by -8 is -1. And then for the exponents, what do we do with the quotient rule with the exponents? Do we add, subtract, or multiply? Since we're dividing, right? What's the quotient rule? What do we do with the exponents?
Subtract.
Subtract. So then we get 9 minus 9. And then we get 12 minus 2. Let's go ahead and simplify that for me, please. So then we get -1, a to the 0, and b to the 10th. Ah, can we simplify anything else further? Don't get tricked. Do we know any other rules that we can apply here?
The 0 exponent.
Yeah, the 0 exponent, a to the 0 is just 1. So then we have -1 times b to the 10th, which is just negative b to the 10th, and we are done. Look how we started with such an intense problem and all those letters and numbers and just got down to negative b to the 10th. That is the beauty of these laws of exponents. All right, anyone have any questions so far? Because you're about to do some practice problems up to the similar level. You guys ready for it? I think you're ready. But do you
I'm still
think you're ready?
copying.
Okay, let me know when you're good to go.
Also the bottom, please. Okay, got it, thanks.
I'm gonna go ahead and give you 3 minutes on this one. And then we have another set of practice problems after this one. All right, let's go ahead and see what you got for A, guys, for A. Be careful, Joshua, because remember the exponent goes to the 12 too, so it's 12 squared, not 12 times 2. There you go. You saw, yeah, yeah, saw the oops. Alright, good, good, good. Okay, okay. Any questions so far, guys? On A, it is Z squared over 144. All right, anyone want to share what they got? Let's go ahead and share what we got for B now. For B, 4x to the 6 to the third power. Excellent. We have 64x to the 18th. If you have 64 to the, you are correct. Excellent job, guys. Excellent, excellent job. Any questions so far on what we did for B, guys? Any questions at all? All right, guys, let's go ahead and share for C. What do we get for C? Excellent, guys. I'm so glad to see everyone added and didn't multiply. Good catch on that. All right, yeah, I'm going to write these answers on the slide for the video purposes. So for A, we should have gotten Z squared over 144 for A. For B, we should have gotten 64x to the 18th. And then for C, we should have gotten Y to the 13th. Excellent, excellent, guys. Any questions on these practice problems before we move on? Anyone need me to work out any of them? Good, good. I'm glad you're getting exposed to applying these rules, guys. All right, let's get into the next slide. Ready? This one's a juicy one. For this one, I'm gonna go ahead and give out a 6 minutes on this one, 6 minutes, because C and D are hella intense. So 6 minutes and give you time to write the other ones out and work those out as well. We'll get into it in just a moment. 6 minutes. Good luck. All right, guys. Anyone still working? That was 6 minutes. Anyone need more time? Last call for more time.
I need more time.
All right, would you need another 2, 3 minutes?
3 minutes.
All right. All right, guys, let's take a look at a squared minus 8 to the 0. Go ahead and input your answer for a now into the chat. Correct. It is 63 because 8 squared is 64. And then 8 to the 0 is 1. 64 minus 1 is 63. Good job, everyone. What'd y'all get for B? We have a couple of twos, we have a handful of twos now. Because Z to the 0 is 1, right? Then we do 1 to the 6, and then which is 1, and then 4 to the 0 is 1 to the 5th, which is 1 again. 1 plus 1 does give you 2. Excellent, excellent. C and D is about to get real juicy in here, so let's see how you guys did. What'd y'all get for C? It is gonna be a fraction of an answer. One over nine, x to the six. Now, Priscilla, is the y to the eighth, is that gonna be in the top or the bottom?
The X is on the top and the Y is on the bottom.
Ah, okay, so okay, good, as long as you know the difference, you're on the right track, good, good, good.
Okay.
Now, if you typed it in like that on my math lab, you'll probably get it wrong, because right there, the 1/9, you're putting that together and the x and y next to each other, putting them both on top. But this isn't my math lab, so you're okay. As long as you know on my math lab, you make sure the y goes on the bottom, okay?
Oh, okay. I see what you're saying.
Okay, okay, look at you guys. So, because 5 squared is 25, right? Then we multiply 3 and 2 is 6. So we get 25x to the 6 over 15 squared, which I believe 15 squared is 225, which has 925, so 1/9. And then y to the 8th, you guys are on point. Excellent, excellent, guys. I'm so proud. Now you can omit the 1 if you want, you can just do x to the 6 over 9th, that, because we know the invisible 1 is there. Excellent, guys, excellent, excellent. All right, let's see how you guys did with D. What did y'all get for D? Excellent, Jacob, for being quick. Excellent, Priscilla. Excellent, Nick. Excellent, Riley. So for D, we're getting negative Z to the 30th power. That is so far correct. Excellent, guys. Excellent, excellent. Any questions so far on any of these practice problems, guys? Yes, I will gladly work out D. So we have the work for D right here. So we're gonna go ahead and distribute the 4 to the top right. So we're gonna get 2 to the 4th. And then we're gonna have Z to the 8th to the 4th power, X to the 5th to the 4th power over negative 16 Z squared X to the 20th. Well, 2 to the 4th is just 2 times 2 times 2 times 2, which is just positive 16. And we know we're power to power, we multiply, so 8 times 4 is 32. Then 5 times 4 is 20th. And then we get negative 16 Z squared X to the 20th. The X to the 20th cancels out, right? Because it's the same thing, or 20 minus 20 is 0, and X to the 0 is just 1, right? So we know we're gonna get rid of that. So we can actually get rid of that now if we wanted to, if you're comfortable knowing if we can cancel it out. Or you can just still do, I'll go ahead and do the quotient rule just to show you. Well, 16 divided by 16, we're dividing these two bad boys. That gives us a -1. Then we're doing quotient rule, so it'll be 32, take away 2, and then it'll be 20, take away 20. So then -1 is there, but you can make that invisible. Z, 32 take away 2 is 30. And then we have x to the 0 power, because 20 take away 20 is 0. But remember, x to the anything to the 0 power is just 1. So that becomes 1. So technically we're doing negative Z to the 30 times 1, which is just still negative Z to the 30th power. And we are done.
I just need a little more extra time to copy the.
Let me know when you're good to go.
Okay, thanks. Okay, I'm done. Thank you.
All right, thank you for the heads up. All right, and we finished the first lesson. We finished the first section of chapter 12. Quite the ruse, right? Quite the ruse indeed. Any questions so far governing the first section, guys? Now, this is what I'm gonna do, guys, because this was we put in 3 hours into this first lesson. Where hands are tired or heads must hurt. So I'm gonna call it here. But we have 5 sections to go with 2 more lectures to go, Mondays and Wednesdays. And this 12.2 is pretty intense. So just so we don't fall too behind, this 12.2 section will be required for you to do on your own with a video of me teaching the lesson. So you'll be taking the notes on your own pace. I'm gonna go ahead and stop recording.